near to your place, please go and visit. Requesting the student as well as faculty, please utilize that opportunity. It is very near to you. And ISRO is the two things. One is the fabrication cost, another is the launching cost. For any satellite, you have to do a fabrication, then you have to do the launching. Both are equally, you have to spend the money. Launching is not that much easy. You have to spend huge crores of money. It is a government, but you are getting suppose 1,000 crores you are spending on one satellite, including fabrication and launching cost, and you have to get the return back of that money. Now ISRO is, when we are launching our satellite, 100 satellites of other countries we are launching. That means fabrication anyway we are spending our money, but launching we are doing our satellite at free of cost with the other countries' money. That is the stage where, that is what is the self-sustainability. You have to get the money from other sources, not depending on every time government, and it is a government means it is a public money. So that's why ISRO is a success story, and nuclear is a success story, defense is a success story, surface to air missiles. Lot of R&D labs are there in Chennai and Visakhapatnam. Because why they are located these two places? You know very well, India, a map is surrounded by 2/3 is water, 1/3 is countries. Pakistan, Bangladesh, China. We always maintain good relations or bad relations with us. We are always want to keep a strategic development between the countries, but they are not in that mode. See, that's why we have a sustainable model, even defense also. In that, but thanks to Abdul Kalam and other pioneers, they have done a lot of contributions, surface to air missiles, even nuclear also. When we invited Bill Clinton in one of our function, Independence Day, every day, he asked to please give a training nuclear scientists of your country to their country. Okay? Because they are using mainly only plutonium, but we are using other radioactive material. See, there are areas we are very good, but there are areas where we have to look into that. But where we are sitting, one is the product development, China is doing very good. Service industry, we are very good. The software, whatever the service industry. But that is not a long life goal. We have to go for product development also. Otherwise, what I said, all industries are shifting to AML, and that amount, paying huge amount, they are tapping that money, developed country, but we are not tapping. We are means our academic institute, mainly talking about. There is a huge gap between these two. Not always studying. You have to apply for practical problems. You have to solve the problems, tap that money, capture that money. See, in that direction, this particular tool is very, very helpful. Suppose you take a simple example, this can be extended to a complicated problem. See, that's where what I said, 3 rules. You apply the boundary condition, three nodes are mandatory. One is here, and sorry. One is here, the another is here mandatory. There is no change in process. But 2 nodes are mandatory. Otherwise, beyond it, in the examination point of view, we take 2 nodes only. We don't repeat that one element and we solve the problem. But we don't want convergent solution. We need marks. We have to complete the problem within half an hour. See, but if you want to give to the industry, you have to specify the convergence criteria, you apply more number of nodes and elements and solve. This is what the first step, discretize. Then the next step is primary quantity, local, global, etc. it will do by the software. Then the primary quantity is nodal displacement, then strain, change in length by original length. Then as per Hooke's law, stress is Young's modulus times the strain. That way we have to find out and see that finally you will get the static equation. This is the equation. If you make these all equations you combine, you will get this is what is the bar problem for linear shape function. Linear shape function means 2 nodes. That's why 2 by 2 matrix for one element. Like that, the number of elements you have to get a global matrix. See, like that you have to combine. For suppose 3 elements are there, 3 local stiffness matrices, 1, 2, 3. Combine this, obtain a global matrix, and then apply the boundary condition, get the solution. This is the general procedure when we are doing in a classroom. But in the software, we will do the pre-processing, processing, and post-processing. Then we will apply the boundary condition, get the solution. Primary quantities, displacements. Then the last step is secondary quantities, stress and strain. So this is the general procedure of finite element method, what we are solving. Or what is this particular structure? That name fixed beam. What is the degree of freedom? Earlier I said 1 degree of freedom. A tensile, one positive x-axis, compressive negative x-axis, shear rotation. These all are bar problems. Here how many degrees of freedom? Suppose I am moving on this platform. What is my degree of freedom? My body degree of freedom. One answer is coming 3. What are 3? See, I am considering a plane. I can move in x-axis translation, I can move in y, I can rotate like this also. Always I should be there on the, otherwise I may fall in that part. See, that's why by following that constraint x, y and rotation, if I can throw this along like this, what is the degree of freedom of this? Catch button. What is the degree of freedom? What are the 6? Rerotation. See, when I am throwing like this, there is an x translation, there is a y translation, x, y and z also. When I am throwing in this position, he will catch in the same position or a different position? Definitely a different position. X rotation, y rotation and z rotation. Now I want to, there is a blackboard, I want to erase this with my hand. I tighten the rope, my hand. With how many degree of freedom? I can remove the blackboard, erase the blackboard.
2 degrees.
Not 2. I can translate like this, I can erase, I can translate like this, and I can rotate like this also. Okay? 3 degrees of freedom. Good, because blackboard is a plane. Now, I am using a chalk piece. Assume it is a chalk piece. Cylinder. Duster is like a prism. Now I am making a cylinder. I want cylinder. Duster is made like a cylinder. I am keeping like this axis. How many degrees of freedom now? Always this chalk piece has to touch with the blackboard. How many degrees of freedom? Blackboard is a plane. Now chalk piece is a cylinder. Generally we are using. But instead of pointing chalk piece, I want to draw the graph, draw the figure. I am keeping in a cylinder vertical axis, like y-axis. What is the degree of freedom? I can translate x, I can translate y. This rotation is also possible. Any other? This rotation is also possible by keeping back the dust, chalk piece on the dust. How many now degree of freedom? 4 true translations and when I am taking a prism type of chalk piece, the degree of freedom is 3. 2 translations and 1 rotation. When I am taking a cylinder, 2 translations and 2 rotation. Now I am taking a spherical type of cricket ball type chalk piece. Now I want to draw something. What is the degree of freedom? 6 is not correct answer. 5 is correct. What are the 5? You can translate x. You can translate y, but z you can't move. If you are moving in z, it is not touching the blackboard. Z translation is not possible. But rotate about x, rotate about y, rotate about z. Is it correct or not? So that's why 5 is like that. You can specify for any engineer, you have to specify what is the degree of freedom of system you are solving first. That is the foremost important point. Like this here, element and nodes means we are defining a degree of freedom. Now, earlier tightening this one. Now I am removing. Up to this, how many degree of freedom? I want to erase 3. X translation, y and rotation like this also. Now I am remove the thread or a rope. Now I am allowing fingers also. I am keeping straight. Now what is the degree of freedom up to this? Earlier 3. Now this is having 3, this is having 3, this is having 3, this is having 3, this is having 3. What is the degree of freedom? 6 into 3, 18. Now in this again sub part is there. Am I correct or not? That is what is the final element. You have to divide into a number of small elements. You divide in such a manner that you increase the degrees of freedom any number. Like that may be 1 lakh, that may be 1 billion or 1 million any time. The software will take care. We don't bother about that. See, that is what we are doing in a finite element approach. That is the discretization first part. Is it clear or not? Actually, in any textbooks, how it is invented is a circle is there. Earlier pi, if pi you don't know how to determine the circumference. before invention of pi. What is the pi value? 22/7. Now we are solving the problem. Let us say pi is given now. How to solve the problem?
Drawing lines at the circumference of the
Circumference outside or inside you draw lines. First draw 4 lines forming as a square. You know the square circumference 4 into a. That is one solution to the circle is not a circle. Whether outside draw a circle or inside. You draw a circle. Instead of 4 sides you draw a 5 side pentagon. That is also a solution. You draw a hexagon. That is also a solution. You draw a heptagon. But at one stage very close to the actual solution, that is the solution you have to find out. The test books they will give this is an example. Most of the tests. Or the finite element method is also invented in such. See, that is what is the approach of finite element method. This is here one out, let us come to here. What is the degree of freedom? That's where actually we are shifted. What is the degree of assume as a plane? 2D problem only. What is the degree of freedom? I don't know the answer. Huh? What is it? Degree of freedom means number of translation, number of rotation. Just now we said we can take 1, we can take 2, we can take 3, 4, 5, 1 lakh, 1 million, 1 million, any number it is. This problem, how many degree of freedom? What is the difference between the previous problem and this problem? Earlier is a bar problem. Load is acting along the axis, longitudinal axis. Now load is acting perpendicular to the axis. We have 2 degrees of freedom per node. One is a rotation, the other is a translation. It can be slope and deflection, or it can be a shear force and bending moment. We consider only one set. We don't consider both. In the form of slope and deflection you take, that's what we said earlier, essential natural boundary condition. Or you can take shear force bending moment. That is your choice. Only that set or this set. We can't consider both. See, a translation or a rotation. Now see, this is the degree of freedom. One is a rotation part, the other is a translation part. The remaining part always same. Here how many nodes mandatory we have to consider? 3 nodes. Why? Because
load is actual.
2 boundary condition, 1 load. These 3 nodes are mandatory you have to consider. Because that is the thumb rule. Load always apply at the nodes only. If you suppose you take a UDL, I am applying the uniformly distributed load